object-based land use classification of West Ottawa neighborhoods to inform up-to-date deer-tick habitat suitability models. An existing ecological niche model uses SOLRIS 2.0 land use data from 2010 to inform deer-tick habitat in the City of Ottawa. Deer ticks are carriers of Borrelia burgdorferi, the bacteria causing Lyme disease. Because of this, tick habitat and the extent of it is of interest to humans, especially in areas undergoing new urban development with increasing human population. Carp, Canada, and Stittsville are areas in Ottawa that are growing rapidly and offer suitable habitat for deer tick populations, as shown by the ecological niche model described earlier. The goal of this study is to create up-to-date 2020 land use covers for the study area to inform new ecological niche models and to provide methodology for future updates that do not rely on the availability of SOLRIS data. Methods. The first step was to download 10-meter resolution Sentinel-2 imagery from Google Earth Engine. The imagery was cloud masked, cropped to the extent of the study area, and contrast enhanced to allow for proper classification of land use types. Once pre-processing was completed, the images were ready for classification. Classification rules were developed using 2015 imagery so that the data could be validated against SOLRIS 3.0 data, which was also from 2015. The classification rules could then be used and applied to 2020 imagery to create new land use data for 2020 with equal accuracy. Ecognition software was used to perform an object-based classification on the imagery. Object-based classification is a two-step process, which starts with segmentation. Using the software, pixels in an image are combined into segments or objects based on their likeness. Following segmentation, the objects were classified as a land use type based on spectral properties. Shown here is a built-up impervious class in red. The study area was classified into 9 land use types, which closely match those of the land use types used in the ecological niche model explained above. Results. The result of the classification was this 2015 land use map, shown here, and the 2020 map, shown here. The results of the 2015 land use cover validation validated against SOLRIS 3.0 data are as follows. The overall accuracy of the 2015 classification is 58%. Built-up impervious, tilled agriculture, and barren land had highest accuracies among classes. Users' accuracies of these classes ranged from 68% to 76%, and producers' accuracies from 70 to 78%. The treed class had a user's accuracy of 45%, but producer's accuracy of 77%. All other classes had accuracies, producers and users' accuracies, which were less than 54%. Conclusions. The built-up impervious classification was the most accurately classified land use type, meaning that in the 2020 classification, it too would be very accurate. Tilled agriculture and barren land were also generally well classified. Overall, the methodology needs to be altered to properly classify all land use types. Alterations would include additions of minimal mappable units for some classes and the use of multiple images from the same year to better identify land use types. Finally, the classification criteria in ecognition could be improved to decrease the rate of false positive and false negatives classifications, and to decrease time spent manually editing each class.